design showing the schematic layout and the sheets schematic. In conjunction with that, we've also got a panel layout design, and you can see depending on which sheet is active depends on which sheet the preview is shown. So there's the whole panel and there's the whole of that schematic sheet. To insert a new part into our project, we can go to our database, and again it depends on which sheet is active. So if we've got the panel sheet active, we get the view of the panel layout model. If the schematic sheet is active, we get the symbol required to be placed inside the schematic. And as we pull it into our project, you'll see it intelligently knows which sheet it's on. So it's presented us with a panel symbol. It's also presented us with valid mounting position, so it snaps very easily, drag, drop and click, snap into the panel sheet. If I go up to here, you'll see it goes into the schematic sheet, and I can place that down in the schematic. Alternately, if we go in here, I can pull out my panel element like so and drop it onto this DIN rail like this. From here we can navigate to the device tree, so it's placed in the schematic, placed in the panel, and we then can place that part into the schematic. So in here I can go and pull out the required symbol for that contactor and place it on there. And likewise, because this is placed in the, I placed this one in the schematic, if I jump to the panel tree, I can then go and pull this device into here like so. So all I need to do is just wire this up now, so I can just do that along the horizontal axis like so, and then just do a multi-connection to give us the three-phase connections here. And then when we come back into the schematic, you'll see that the logic is updated, so we've got the connectivity there shown between the pins, and I can right click on here and do panel auto connect. So it adds those wires for us in the panel. So that's a fully integrated panel system without the need for any complex mechanical modelling to be done. Of course, interaction takes place is we can then transfer this information from the E3 design, because although we're actually looking at this inside a 2 dimensions, there's actually 3 dimensions to this, and if I hit the 3D button here, you'll see that we're now able to, like so. So we can get clash detection, and obviously it gives you a good idea of what the 3-dimensional look and feel of that. So for the electrical engineers, there is no real need whilst doing panel design to go into the panel, but where we will need to go into the panel is where we go to transfer the information from WireWorks into our 3D model for envelope and space requirements within the panel design. So if I select all of this box here, go to my file and export that as a step file, we can save all the elements, including the wires if we want to, any drill breakouts, restricted areas, callouts, and I'll save that into here. And then from inside our SolidWorks, we can then import that model into our SolidWorks by going to File and Open and browsing for our step file. We can open that. So once we've imported our step model, we can then just bring that in to our main assembly by obviously using SolidWorks. So that can be placed in our building to give us our space envelope. You'll see in here we've already got some a panel placed inside here, where we've got some routing or routing where it goes to an emergency switch here to the panel. There's panel into panel wiring, there's wiring to the motors, and all this information is come from WireWorks. So the panel itself with its envelope and all of the harnessing information in this particular model has come out of WireWorks. To find out more, please visit E3WireWorks.com.